Hi guys, my name is Keshav and I'm from Texas. So you wanted to learn about DNA replication. Well, DNA by the K-pop group BTS, you could say was replicated by our very own Kendrick Lamar. But that's not the type of DNA replication that we're looking at today. So yes, we are talking about DNA, deoxyribonucleic acid, probably the most complex molecule that has been discovered by us humans. DNA, as you probably know, is a nucleic acid, one of the four major types of biological molecules. Nucleic acids are structurally polymers, which means each nucleic acid is made up of smaller parts called nucleotides for DNA. Each nucleotide is also called a monomer, as many of these nucleotide monomers make up nucleic acids to become the basis for what makes up DNA. Let's quickly look at what makes up each nucleotide. First, we will need a 5-carbon sugar called deoxyribose. See the resemblance from the word DNA, deoxyribonucleic acid. The second piece that we will need is a phosphate. These phosphate groups hinge onto our deoxyribose and voila, we have the backbone for our double helix DNA strand. Lastly comes the famous fantastic 4 nitrogenous bases, adenine, guanine, cytosine, and thymine. Simply stated, these are the links that hold together our DNA. The nitrogenous bases can be only paired a certain way, so the adenine can only be paired with thymine, and cytosine can be only paired with guanine. These are called base pairs. The AT pair is held together by 2 weak hydrogen bonds, and the CG pair is held together by 3 weak hydrogen bonds, making it slightly stronger. But now what about our dear friend RNA, ribonucleic acid? What's he all about? Well, RNA is similar to DNA, except there are a few major differences. But the main difference that you need to worry about is that it has uracil instead of thymine, which is another nitrogenous base. So now to the replication. It's not as complex as it may seem. The first thing that we need to know is each time DNA is replicated, half the original strand is left. And it is split by an enzyme called helicase. What this enzyme helicase does is all it does is just split these enzymes and the bonds that held together each of the nitrogenous bases. So the leading strand is what we call on top and the lagging is on the bottom. So now we have reached a stage of replication. So our top leading strand is an enzyme called DNA polymerase. All it does is it fits in the other missing nitrogenous bases that are not there. Our lagging strand, friend, is a little bit more tough. It requires an enzyme called RNA primase to start placing the nitrogenous bases, and later in the DNA polymerase comes and places the rest of the nitrogenous bases because the strand on top, it goes in a direction called 5' to 3' direction, while the one on the bottom, the lagging strand, goes from the 3' to 5' direction, making it kind of tough for the DNA polymerase to do its job. So the lagging strand places the Okazaki fragments in lines of 1 to 2,000 nitrogenous base pairs so that the DNA polymerase can finish its job. So that's about it. I mean, that's just the main basics of it. So I guess we can learn to appreciate how amazing our DNA is, and for every millisecond, yoctosecond, femtosecond, just learn about what are amazing things your body can do. Thank you.